Right, so this is the last video part of this pure textbook where we're going to be looking at vectors. So we're going to be looking at 3D vectors and using it in real life situations. So first things first, we looked at vectors in the first book where we looked at it only in 2 dimensions where we had our x and y axes, and therefore we can write a vector in the form of something I plus something j. Okay? We're now going to be looking in 3 dimensions where we have our z axes like this. And so now we're going to look at AI plus BJ plus CK. So this K value represents the Z positioning. Okay, but the methods are still the same. What we learned in the Pure 1 book is the same. It just applies to now IJK as well. So you can rewrite this in column form, saying IABC like this, which will represent IJK in the column form, and also like multiplying it, adding and minusing it. It's all the same stuff. Also, if we can find the distances, right? So the distance equation is now x1 minus x2 between 2 points squared plus y1 minus y2 squared. And now because we have a z-axis, we should also do z1 minus z2 all squared. And then this will give us the positioning or the distance between 2 points on the axes. Also, we looked at finding the magnitudes as well. We can also find the magnitudes. Let's say, I'm going to call this, let's say, A is 2i plus 3j plus 4k. We can find the magnitude of A by just doing 2 squared plus 3 squared plus 4 squared, which is 4, 9, 13, so 26, root 26 like this. We also looked at how to find the unit vector. So remember the unit vector was a vector with magnitude of 1. So as you can see here, the magnitude of A is root 26, right? So we want a unit vector of A hat, we call it, which is equal to A over the magnitude of A. So this still applies. So we have A hat is equal to A is 2i plus 3j plus 4k. And we just divide it by the magnitude, which we found earlier as root 26. And this would be the unit vector of A, which has a magnitude of 1. So this part is all stuff we've learned previously, but now we can looking at finding the angles between a vector and an axis. So this is finding the angle between the vector and positive axes. Okay, so if we have a vector in the form, let's call it AI plus BJ plus CK again, then the angle cos theta x is equal to the A value over the magnitude of A. The value cos theta y is equal to B over the magnitude of A, and cos theta z is equal to C over the magnitude of A. Right, this might seem a bit confusing, but I'll explain now. So if I was to draw the vector 2i plus 3j plus 4k again, so it would be 2i 3j plus 4k, then it'll be roughly here. Okay. Now these equations tells us the angle this vector makes with the positive axis. So if I was to plug in my A value, which would be 2 here, 2 over the magnitude, which is root 26, and do it inverse cos this, then I'll get a theta x value, which will represent the angle it makes with the positive x-axis here, which will be this angle here. If I did 3 over the b value here, which is 3, over the root 26 again, and find theta y, then I'll be given the value of the positive y-axis. So in this case, it will be this angle here, because this is the positive y-axis like this. And finally, if I did the c value, in this case the k term, so 4 over root 26, and find my theta z, then this will give me the axis it makes with the positive z-axis. So the z-axis is here. So the positive z-axis will be this angle here, theta z. So these equations tells us the angles the vector makes with the positive or each positive axis. But apart from that, that's the only extra information that we really need to know about 3D vectors. And as I said before, we can now apply this to more geometrical terms and apply it to real life situations such as mechanics.